All right, good morning, everybody, and welcome to today's webinar hosted by SATIB. We are thrilled to have you with us for what promises to be an insightful and engaging discussion on some of the current pressing challenges in the insurance industry today. Our topic, Bridging the Gap, will focus on critical issues such as insurance capacity challenges, fire risks, and the real costs of being unprepared for these inevitable challenges. As our industry continues to evolve, it's vital that we address these areas head-on, and we are fortunate to have a panel of esteemed experts to guide us through this conversation. Allow me to introduce our panelists for today. I am Nick Constantidakis, and I'm an account executive for SATIB, and I head up the Lowveld region. We then have Johan Botha, who is a seasoned fire investigator with more than 27 years experience in origin, cause, and determination within residential and business premises and structures, passenger and commercial vehicles, trains, aircrafts, vessels, wildland fires, and mining industry. Johan also served in the South African Police Services with 24 years experience, 7 years at the Special Guard Unit for close protection and senior political figures. He relocated to the Forensic Science Laboratory and commenced his training and became a forensic fire investigator as a senior forensic analyst, captain for 16 years. We then have Kashan Singh, who is a seasoned fire and forensic investigator with 7 years of experience in fire scene examination, origin and cause determination, as well as forensic evidence analysis. With a strong background in both fire science, he has also worked on a wide range of cases, including structural fires, vehicle fires, and arson investigations and fire risk compliance assessments. We then have Werner, who is a licensed professional electrical engineer with over 12 years of experience in post-loss electrical investigations. Werner is well versed in the failure mode and comprehensive root cause analysis of complex and integrated engineering systems within the electrical utility industry. His experience includes all aspects of power system failures at high, medium, and low voltages, large power station multi-unit failures, electrical protection, transformers, current and voltage transformers, switchgear, power lines, earthing, and lightning. With a strong foundation in engineering principles and advanced failure analysis techniques, he provides objective, science-based evaluations to uncover the root causes of accidents, damage, and system malfunctions. Then we will have Mariette Sutherland, who is a professionally registered quantity surveyor with 20 years of experience in the construction industry. She joined Cedrix in 2022, providing professional services, including, but not limited to, the completion of repair estimates, value at risk calculations, overseeing of reinstatements, and reporting to insurers. Mariette is a registered quantity surveyor with the South African Council for Quantity Surveying Profession and a professional member of the Association of South African Quantity Surveyors. And then finally, we have Pieter de Vos, who is a senior, major, and complex property loss adjuster at Cedrix South Africa, based in Johannesburg. Pieter is part of Cedrix major and complex loss division, specializing in the handling of intricate insurance claims. Pieter has adjusted numerous large and complex fire claims, ranging from 3 million all the way up to 250 million rand plus. Pieter has been in the short-term industry for 23 years and has been adjusting for 12. Pieter is a member of the Insurance Institute of South Africa and the Institute of Loss Adjusters. So we encourage you to participate actively by submitting your questions throughout the session. Our panelists will address these during the Q&A segment at the end of the webinar, and we look forward to fostering a lively discussion. Thank you for joining us today, and let's get started by hearing from our first speaker. Johan, feel free to take it away. Thank you so much.
Good morning, everyone. My name is Johan Botha. I'm the head of EFI Global Africa. So EFI Global is an international organization with a footprint in South Africa and a vast growing client base in Africa and abroad. So EFI Global in South Africa was launched on the 1st of July 2019. And we operate as an impartial consultancy service within Cedrix South Africa. Our clients include insurers, legal firms, corporates, other loss adjusting firms. We provide impartial reports to court compliant standards. Our team of experts is extensively trained to handle any size of loss. The law firms, mining houses, and all those industries. And Kishan, you can go to the next slide. Yeah, so I'm the head of EFI Global Africa and also the lead of the fire forensic team. Then we have Elise, our lead operations and business support. Werner Sieberg, who's the lead forensic engineer. And Billy Buitendag, lead environmental team. And Jan Gomez, who's a lead specialty consulting in our product. Next slide. So there's our environmental team. We've got Willie, he's a lead. And then Alan Bardenhorst and Johan Kriek, he's a geohydrologist for us. Then it's myself, Kishan Singh, Jacob Lekocholo, Gary Kemp, and Andrew Muketsi. Those are the 5 investigators at EFI. Gary Kemp is based in Port Elizabeth. And then we've got Werner Sieberg, he's a lead. And then Ivan van Staan is a mechanical engineer. Vukosi Mbuweni is an electrical engineer and he's got his master's. And then under specialty consulting, we've got Vian Gomez, who's a chemical engineer, and Mari Smith, who's a metallurgist, and Natalie Sloan. She's also a fire investigator, and she is based in Mauritius. And then we've got our operations business support. Elise is the lead there, and then we've got Monica Pinar, Rina Furi, and Ursula Allen. And that's in a nutshell, EFI Global. Over to you, Kishan.
Cool. Good morning, everyone. Thank you for your time. I do appreciate it. So yeah, we've been tasked with addressing thatch structures, the risks and the relevant insurance issues or aspects surrounding thatch buildings. Um, I think it's best to start off with changing in the risk environment. So not much has changed, but where there are changes, it is significant in the increase in risk. So, as we see on the slide, new technologies and the desire to be grid independent has led to the increase in the routing of electrical reticulation, resulting in the risk of electrical fires in commercial and residential occupancy. So, this doesn't just apply to your thatch buildings. We've seen significant increase in fire risk and the amount of incidents in your residential and commercial buildings where you have your ordinary structures and also your thatch roof structures. So again, it's not just specifically to thatch, it's a concern in the general industry. What also is quite concerning, and we've seen a multiple installations spanning over the past 3 years of your flue fireplaces or your fireplaces constructed with a single or double sleeved flue that extends through your roof structure. So space heating has become more popular, especially in the installation of double sleeved and flue jackets, where these are more aesthetically pleasing. You don't want, or clients these days prefer moving to this installation rather than your historic chimneys that is constructed of brick and mortar because they look nice. It's more cost effective to have them installed. You don't have to break large sections off your roof, less materials used in its construction. However, these pose quite a significant risk and even a greater risk than what we see with your ordinary chimney constructions. So, top preventable causes, and again, we've mentioned your flue chimneys and your electrical reticulation. In terms of fire risk, these are your main 2 causes, I would say. Um, yes, we have your wildfires and the spread of fire from a wildfire onto your thatch buildings, but the insured can take steps to prevent wildfires and as well as with your flue chimneys and your electrical reticulation. However, we've seen that with wildfires, there's only so much you can do. You can implement your fire breaks, You can have a regular maintenance inspection or upkeeping of your vegetation. But in terms of where they can be actively or can it be proactive in a greater sense is the adherence to compliance when it comes to the installation of flue chimneys and the routing of electrical reticulation within the roof structure for your ordinary lighting circuits, your branch circuits, and especially for your inverter systems. Also, we're looking at acts and omissions leading to claim repudiation, non-adherence to risk reduction requirements, and non-adherence to general legal and regulatory requirements. We have in a later slide summarized some of those legal and regulatory requirements. Um, Unfortunately, and it's been like this for many a years since the introduction of your deemed to satisfy requirements, where not a lot of emphasis has been placed on risk mitigation in terms to the thatch structure itself. It's quite short. I wish they would address it more comprehensively or more detailed. And then finally, scene preservation, spoliation, and prejudice. So as I mentioned, just a summary of your legal and regulatory requirements. As we all know, the National Building Regulations and Building Standards Act is the act that governs the construction for any building, ensuring life safety as well as structural stability and protection of assets. They're enabling standards. So the regulations or the deemed to satisfy requirements that need to be met, we can also call it the minimum requirements that need to be met to ensure compliance with your national building regulations applicable to buildings, and in this instance thatch buildings as well, is SANS 10400 Part T, the latest edition being 2022. I stand under correction. I believe 2024 may have been published as well. I will just have to double check that, which is again the application of national building regulations in terms of your fire protection overall. Now, within SANS 10400 Part T, it makes normative reference to other standards. When normative reference is made to a standard, it must be adhered to as well to ensure that all of the standards read together, ensuring compliance in terms of your national building standards. In particular interest again is SANS 10400 Part V 2018. That is the latest. It speaks to space heating. So the regulations are deemed to satisfy requirements that need to be met in terms of the installation of your chimneys and flues. SANS 10313, protection against lightning, and SANS 62305 is the same. They speak a little bit, or they relate to each other, but there are variances within those two codes, and they both speak to physical damage to structures and life hazard, and physical, yeah, as I said, it's a little bit of a repetition. Part T, you can see there's a lot of wording on that slide. I'm gonna do my best not to read through all of it. I find it a little bit hard to summarize it because you have to read the entire requirement in its entirety to fully understand what they want from us. However, a lot of your fire protection requirements stems from your occupancy classification, which you can find in SANS 10400 Part A. And in Part T, a lot of what you see on the slide now relates to 4.2, which addresses your safety distances. So your safety distances is stipulated according to your fire load present on your occupancy and the openings in which a fire can spread from the ignition of the fuel load present in a particular compartment. Now, however, when looking at a thatch building, the entire roof is considered a combustible fuel load, which poses a risk to neighboring properties as well as to adjacent properties or buildings on the same property. So we see safety distances stipulated in 4.2 shall be applied and treated as a high fire load when calculating safety distances. There is a caveat under table 4.2 or the table within 4.2, where they provide a calculation. Um, Now, your calculation on your safety distance to any boundary or adjacent building does vary depending on how your roof is treated. But again, I'm not going to jump into the calculations. I feel that's unnecessary for this presentation. So buildings and LAPAs with a thatched roof plan greater than 300 square meters, or where it is closer than 4.5, just summarizing, to the boundary, and the safety distance from an existing building derived from 4.2, the table where we see the minimum stipulated distances, shall have additional fire protection systems, that being post-treated, the thatch itself post-treated on both sides, pre-treated as a permanent system, or any other system. Problem is, any other system needs to be designed by a fire engineer. And again, that will involve a rational design. I'm not going to jump into that right now. Buildings and LAPAs with a thatched roof in areas with a lightning flash density greater than 7 strokes to ground per square kilometer per year, and that's according to SANS 10313, or where conductors or wire sways are used in the thatched layer, shall be provided with a lightning protection system designed and installed by a competent person in accordance with the relevant standards. Now, if you do have those wire sways and they are used in the thatch layer, they also shall have lightning protection systems installed. I believe Werner could elaborate a little bit on that later in our presentation. Can get a little bit complicated. Um, we have seen these systems fail, but they are very useful. Just a quick illustration of your safety distances. When your chimney does protrude through the roof structure, they must be at least 1 square meter radius away from the roof structure itself. And again, just to illustrate the risk of this new fireplace installations, we've got a small little case study. A fire occurred in a main building or communal area of a game lodge to which various rooms were attached, resulting in the total loss of that building. The area of fire origin was the secondary seating area at an elevated level where a fireplace was installed. Your ignition source was the heat energy generated by the escaping flue gases. Material first ignited the thatch roofing material and caused poor workmanship, resulting in the improper use of binding wire between the internal and external flues used to secure the insulation material through which heat was conducted to the thatch roof. Just a small little image of a section of the building rather. And in the center image, we have the double sleeve flue where you can see clear oxidation and thermal discoloration. And the final image on the right hand side is the original installation where your double sleeve flue penetrated through the thatch roof material. And of course, that's where we identified the fire to occur. So the double sleeve jacket was examined and a destructive analysis was conducted, which entailed cutting open the outer sleeve or jacket. The following observations were made when this was done. The outer sleeve or jacket was fastened to the inner sleeve using rivets. Insulation material, which was inserted between the two sleeves and fastened around the inner sleeve using a metal wire. The metal wire penetrated the insulation material, resulting in heat transfer by means of conduction from the inner to outer sleeve jacket, and also then transferring the heat to the thatch material as well. As you can see, this is when I cut open the outer sleeve. It's clear that there was heat conduction of the wire to the outer sleeve with the clear demarcation line in the last photograph at the bottom of the screen. So again, just running through another one. I'm going to be as quick as possible. We still have our other presenters that need to go through their material. We have H3, which is a domestic residence, a fireplace. However, in this instance, a single flue installed in a living room and extended through the ceiling and roof void. The sections of this flue pipe were fastened together using clamps, and it was installed too close to the wooden rafters. The installer also stated that they did use insulation material. However, they wrapped it around the single sleeve flue or just the flue pipe itself, and this dislodged, resulting in the conduction of heat as well. So luckily enough, the insured was able to break the ceiling, and he had a few extinguishers on hand and was able to reduce the fire damage. And as you can see, in the third last and the bottom picture, your thermal discoloration and also the charring on the wooden rafters from the hot gases escaping and the conduction passed on to the wooden rafters. And that takes us over to Werner. But before I pass over to Werner, just a little quick note. There is a misconception in the industry that this insulation material is adequate or effective. Now, normally it is rock wool or a ceramic insulation material that is designed to withstand heat for a particular life cycle or span. Um, it's not designed to be imposed or impinged with heat over a long period of time. They will fail, they will degrade, and you will have hot gases and heat being transferred through your flue pipes. Cool. And Werner, I shall pass over to you.
Thank you, Kashan. And yeah, good morning to the audience. It's a privilege to be with you. The way in which I've decided to structure this part of the presentation is to address certain aspects of SANS 10142, Part 1, which is the 2024 version. I've specifically looked for aspects that deal with fire risks, that deal with thatch risks. I think Kashan has dealt to a certain degree with lightning risks, and so there are other standards that apply to that. I think for today's presentation, we'll deal with the electrical risks specifically pertaining to thatch. And we'll start with section 5.2.2.2, which states that if electrical equipment has to be mounted in a fire risk area or adjacent to flammable material. Now, just quickly to pause here, thatch is both a fire risk area and a flammable material. And so both of them apply. It shall be of or enclosed by thermally non-conductive and non-flammable material. Now, the four images below, I might be proud to add, are generated by an AI. The one on the left is a metal conduit with a metal kind of connection box, which is mounted in proximity to the thatch. Very often you'll find that electrical and reticulation needs to be routed through such area for either lighting or other purposes, going to a second floor or something like that. So it is obviously a non-flammable material, but it is certainly not thermally non-conductive. Okay. And so number A actually requests or requires that it must be thermally non-conductive and non-flammable. And so the heat conduction from an electrical fault in such a box would probably cause pyrolysis of the wooden structure behind it, and perhaps also then of the thatch above it. Right. Then the second box, and I mean, in many instances, these electrical boxes are of flammable material. They are enclosed, yes. So oxygen flow to the point of electrical failure or to the point of ignition of a fire is very often limited. But once the plastic casing of such boxes then melts and additional oxygen is added, and if in such conditions the electrical fault persists, then the mounting position of these boxes becomes very critical. So there are obviously non-flammable, non-conductive fiber type boxes that you can install in these kind of circumstances. Because then, clause B and C basically state that it shall be so designed or positioned or both. So I think the middle two pictures are basically if you can ensure that it is a non-thermally conductive, non-flammable material, the mounting position could potentially be near the thatch, right? Because the preposition between A and B and C is definitely an or, and I've actually highlighted that in bold. Because if you adequately ensure that it is non-flammable, non-conductive, you don't need to pay attention to number B and C. But I think one must also kind of be rational and be cognizant of the heating effects. So number B says it must be so designed or positioned or both that the flammable material is not subject to any hazardous heating. And here, I think I just want to draw the audience's attention to the fact that it's not that you have to do a certain thing, but you have to ensure a certain outcome. In other words, you have to ensure as designer of this electrical reticulation that the flammable material is not subject to any hazardous heating. The way in which you do that is entirely up to the designer. But adherence to this standard then requires that any location of the electrical installation that might fail must be as far as possible removed from this flammable material to prevent the hazardous heating. Right, and then also hazardous heating, I think B and C go together because electrical arcs and sparks are very often where hazardous heating occurs, and that the hazardous heating and the electrical sparks must then both be included and enclosed, and the hazardous heating must not get to the thatch, which is obviously very flammable. Thank you, Kashan. Next slide. The next clause that I've just decided to address, it's probably not as relevant, but perhaps in older buildings it might be. So 6.4.5 says that open wiring consists of a single core insulated conductors that operate at no higher than 250 volts. So 250 volts, I believe that's just the normal standard distribution voltage. But so then on the left here, we've got once again an AI generated image of open wiring. Basically, this is a 3-wire plus earth, and basically the insulation of the conductor is only one layer. In other words, behind this red and white and black, there is the copper. As opposed to the right-hand side, which is basically just a normal surface wire, the earth might not be in an insulator, and you might just be surrounded by the sheath. But the red and the black, which is the live and the neutral, are number one, insulated with their own insulation, and number two, also protected by a protective sheath, which is basically the plastic covering that goes around all, the live, the neutral, and the earth. So 6.4.5.1, this above, we're just in the definition. Open wiring shall not be installed under thatched or wood shingle roofs. This is quite important, obviously, in a thatch environment. And also then where it will be in contact with flammable material. I think this is quite straightforward. I just thought I'd put it out there. In instances where there's a bit of an older wiring system, we might need to consider that. All right, thanks, Kashan. So 7.9.2.4.1, it's quite a long sequence of subclauses. Bare conductors. Now, a bare conductor is basically completely uninsulated conductor. I just want to place this in context. I think it's the last 15, 20 years, not as much anymore, but where conductors are actually spanned, from one end of the room to the other end. And it's actually because they're above ground and because direct access there to, from a person is not really likely. It's fine if those conductors are non-insulated. And so, I think of an art gallery, for example, where, the lamp then connects to both these bare conductors, and the lamp then sources from the live and the neutral and illuminates the room. So such bare conductors, obviously there is a human safety aspect to it, but today we're addressing specifically the fire risk. So they may only be used in an extra low voltage lighting installation. Right now, I just quickly want to quantify what I mean by that. There is a filament lighting. How to explain this? So it's a bit of an older lamp. It's not an LED lamp, but it is a filament lamp which gets quite hot and that operates at low voltage. Now, if you want to achieve a certain illumination or a certain power dissipation in the lamp with a lower voltage, that effectively means that your current has to be a bit higher. And current always goes with additional heating. And so these lighting systems are allowed, but they must comply with 60598 Part 2, Part 23, which is basically luminaires and particular requirements for extra low lighting systems for filament lamps. So there is a standard, which I'm not going to go into now, but Part C then also requires that the conductors must be at least 1 meter from thatch. All right, from the thatch, under a thatch roof. Now, the illustration basically says that, in any direction, these conductors can't be within 1 meter from thatch. The problem I have with this requirement in the context of, a lodge, for example, is that your lighting needs to be somewhat, higher than what a person can reach, and also needs to be high enough to illuminate the room. And the conductors, or the bare conductors, are very often spun between the two walls of the room. Now, if the thatch actually gets to very near to where the position where the bare conductor is being strung from, that requirement can no longer be met. And so I just thought to point that out. There is obviously a reason why this requirement was brought in. And the designers will need to be very creative in terms of how to adhere with this requirement while also kind of, making the place appealing. Thanks, Kashan. Next slide. Right, now let's move to specifically the mounting of luminaires. And I think in this illustration, you can also just see the specific filament lamp that I'm speaking of. It was very much in fashion in, let's say, 15, 20 years ago, not as much now with the rise of LED lamps. The selection, for the selection of luminaires with regards to the thermal effect on their surroundings, right? So we can all agree that these lamps do get kind of hot, and that the fittings and the holders of these lamps need to be specifically designed for that purpose. So the following features shall be taken into account, and here I just wish to pause again to say, very often a standard is quite prescriptive in terms of what you can do, what you cannot do. What the end of this clause basically states is that the designer or the person that wires this premises needs to take into account. In other words, he needs to make a decision and needs to make a rational decision in terms of the amount of heat that is expected from a light. And so the position of this light currently in the close proximity to the thatch, to me, is irresponsible. And so if it was designed and installed in this manner, that would mean that the designer or the installer did not take into account, number A, the maximum permissible power dissipated by the lamps, right? And the corresponding heat that is generated by the lamp. And also the fire resistance of the adjacent material. In this context, for example, there's no fire resistant material at all between the lamp and the thatch. So at the point of installation and in the thermally affected areas. So this is basically the heat radiating upwards or towards the thatch from the lamp during operation. And then also number C, and now we're working downwards. So the minimum distance to combustible materials, including materials in the path of the spotlight beam. So this is not necessarily a spotlight, it's more of a floodlight that kind of the light disperses from the lamp. But for example, if thatch were to be placed, below the lamp, where the radiated heat from the illumination could reach that thatch and could possibly cause hazardous heating, that would certainly have to be considered. And so basically one needs to do a rational design and take all precautions to prevent the outcome of a fire occurring. Okay, thank you, Kashan. So then carrying on with basically protection against fire risk, depending on the fire resistance of the material at the point of installation and in the thermally affected areas, right? This is above and below the lamp. The manufacturer's installation instructions shall be followed. That's also very important because manufacturers also very often dictate or say, this is the amount of heat that you can expect to be generated by this lamp. So marked luminaires shall be selected and installed according to marking instructions. So if there's a marking on the lamp specifically that states, you have to keep this such a distance away from flammable materials or combustibles, that needs to be taken into account. Then the next subclause, sorry, not going to read all those numbers. At least 200 millimeters of the conductors leading from the ELV lamp to the holder shall be 180 degrees, which is class A flexible conductors, such as silicon rubber insulated conductors. So it's a high temperature insulator. The lamp holder shall also be suitable for an operating temperature of at least 180 degrees, just because of the fact that these lamps get quite hot. Then the extra low voltage power source cannot be installed above the lamp or within 200 millimeters from the lamp to any side, unless a heat barrier is installed between the lamp and the power source. And the main reason for that is because the power source, very often being a switch mode power supply, also has a certain heating characteristic, gets hot, and if you then have two heating sources in close proximity to each other, they'll basically affect each other and cause further heating, and then also hazardous heating. Right, who can do a electrical risks presentation without addressing joints and terminations? Because I believe not just in thatch environments, but also anywhere else in the hospitality industry, joints and terminations are generally the greatest fire risk. A joint will always introduce a certain amount of resistance, series resistance in a conductor or a cable. So 6.3.7 is a joint and termination. A core and conductor shall be made in accordance with manufacturer's instructions. So once again, if there's a manufacturer's instructions and there is an instruction in as regards to how to make a joint, that needs to be taken into account. And then there's an OR. It needs to be the appropriate part of SANS 10198, part 10 and 11. So that deals specifically with cable joints. Also more in the context of large caliber, large gauge cables, but also applicable to smaller cables. Right, flexible cables, which is the three cables that you see below, shall only be joined using termination boxes, cable couplers, or manufacturer's joining kits. So the left is then the termination box. Once again, non-flammable, non-thermally conductive termination box. Cable couplers, which is basically, in the context of solar installations, you guys might know the MC4 connector. But this is basically just a cable coupler, a purpose-built cable coupler, which then also connects to the both ends of the cable using a crimp, right? Which is also indicated on the right. So the manufacturer's joining kits basically have certain gauges of crimps that apply to certain gauges of cable. Also very important to take into cognizance the fact that a crimp or a ferrule is designed for a certain size of cable. And so if you use a crimp, a ferrule that is too big, that'll result in undercrimping and will result in insufficient contact between the cable and the ferrule. All right, next slide. Right, what not to do. Joints and terminations shall not adversely affect the current carrying capacity of the insulation or the insulation resistance or the earth continuity of the cable, core, or conductor in which they are made. Now, once again, I wish to point out that it is not a particular requirement of what you must do or what you must not do, but it is a requirement of outcome. In other words, if I chase a high current through a cable that is continuous and I chase the same current through a cable that contains a joint, the resistance or the heating patterns of the continuous cable and the one where a joint is included must not materially differ. And so it's an outcome-based requirement. Right, number B, it must not be made in any connector, bend, or elbow, or T-piece of a conduit. So conduits are obviously, either the PVC or the steel, galvanized steel pipes that these conductors are routed through. Also, just as regards another requirement or set of requirements in the same standard. Right, I just quickly want to address the bottom two pictures before I carry on to number C. So the bottom two are basically what I find quite often in electrical installations, where two cables or two conductors are basically twisted around each other. The premise or the idea of the person making this joint is that as long as I make the surface area between the two conductors that I need to join big enough, and as long as I give it enough twists, surely the contact area will be sufficient. Now, the problem with that is that you're relying on spring loadedness of the connector or the material, the copper. And over time and with vibrations and with thermal expansion and heating and all those things can change the material properties and the spring loadedness. And so that the two kind of helically wound conductors can become loose from one another. Particularly if one doesn't make sure that either the screw or on the right hand side this cap, the ceramic cap, actually holds them in place and that they remain in place. So my view is always, if you want to make sure that a joint is made properly, use a crimped ferrule, use a correctly sized crimper, use a correctly sized ferrule, because that piece of metal is going to deform and it will stay in that position, ensuring adequate contact. Now, number C and D, sorry, just the previous two. Number C and D deal with basically the same thing, but you must not allow the strands of a stranded conductor to spread. And obviously the second from right picture is a kind of grotesque in that regard. The conductors are very spread, and once you connect that with the right-hand side of the cable, there will not be sufficient contact between the two sides of the joint. And that'll also result in a loose connection, a hot connection, and in the end, it might result in a fire. And then number D, it must not require the strands of a stranded conductor to be cut away to allow the connection of the conductors, for example, to terminals. So on the right-hand side, we've got a terminal. I'm not sure if it's visible on the picture, but some of the conductor strands were cut away. Otherwise, there would not have been sufficient space to insert it into the circuit breaker or the switch. And my caution in that regard would be, a conductor sized for a certain current, and it needs to be sized it needs to be of that gauge all the way through into the terminal, not just up to the terminal. And so if you cut certain, strands away, that will take away the current carrying capacity of the conductor in that area, and may also then result in a hotspot and a fire. Yes, and that's all from my side. Thank you very much. On to the next speaker. I think this is Peter and Mariette.
Yes, thank you, Werner. Happy Friday, everybody. So just to touch on the physical upgrades that most reduce perceived risk. We touched on fire breaks earlier on, but obviously impact of the fire breaks are essential in mitigating wildfire risk. especially in rural or forest adjacent properties. I think that speaks for itself. I think what we need to remember is also depending on the wind of the day. I mean, yeah, if there's a thatch in the area and you've got hot embers flying around, you're going to have a problem. Fire breaks act as barriers that deprive wildfires of fuel and slowing or halting their spread. Best practices in terms of your fire breaks would normally relate to maintaining a clear zone of 10 to 30 meters, depending on vegetation and the terrain. Use gravel paths, bare soil, or low flammability vegetation. I think that speaks for itself. And to obviously regularly inspect and clear debris, especially before the fire season. And then you need to coordinate, and the insured needs to coordinate with the local fire authorities for optimal placement. I know in the Nelspruit area, they use LEFPA, and you can contact them and they can give you a permit to conduct a fire break on your premises during a specific date and time. In terms of isolators and that sort of thing that we're going to touch up here now, I think obviously from what Vander said, it's quite obvious that impact is crucial for reducing fire and electrical hazards. You know, what we can obviously, I think that also speaks for itself, and you know, electrical fires are going to be reduced. We're going to reduce potential damage to equipment and injury to persons. Why does it matter? So isolators allow safe disconnection of systems during maintenance or emergencies. Best practices include the installation of lockable isolators for high voltage systems to ensure compliance with the local electrical codes. Very important, obviously. And you need to conduct routine testing and include isolators in emergency response plans, and then use arc fault detection devices for added safety. Okay, so when you're talking about maintenance programs, clearly the impact thereof, it prevents unexpected failures and extends assets life. Why it matters? Well, proactive maintenance reduces downtime and claim frequency, which is obviously important for insurers and brokers alike. Best practices would include, but not necessarily limited to, the implementation of computerized maintenance and management systems, to use predictive analytics. Examples thereof are vibration sensors, thermal imaging, and the like. Good ideas to keep detailed logs of inspections and repairs, and obviously to train staff on early fault detection techniques. In terms of additional upgrades, I think we all know about the basic fire suppression systems, as sprinkler systems in warehouses and that sort of thing. They are not always, they cannot always be installed depending on the business that the insured operates. Obviously, in my experience, you can actually, you know, cause more damage with a sprinkler system than without it. But yeah, I suppose that just depends on the risk. Normal extinguishers, you can have your fire extinguishers, your hose reels, and that sort of thing. Strategically place these for manual intervention in the case of an emergency. Security systems in South Africa, most of us have CCTV at home and in our companies. Well, they deter theft, pardon me, which remains to be seen in my opinion, and it provides evidence. Now that's obviously what we'd like from a loss adjusting point of view. And then obviously access control, which is all over the place. I mean, you can't get into any corporate space now without access control. And then lastly, structural reinforcements, flood barriers, wind bracing, and seismic retrofitting, which are especially important in climate sensitive zones. Normally we don't really have big tsunamis and that sort of thing, but we'll see if that changes over time. And then Mariette is going to talk to us now on the market valuation versus insurance rebuild valuation. This is a very hot topic. It comes up on most claims that we attend to. So thank you for your time, and over to Mariette.
Everyone. Yeah, it is quite a contentious topic, market valuation versus insurance rebuild valuation. Now, understanding the distinction between these two is vital for accurate insurance coverage and financial planning. Now, let's first look at market valuation. The definition thereof is it reflects what a buyer would pay for the property in the open market. So it includes your land value, location desirability. I mean, you've all heard location, location, location. This is where this term comes in. Market trends and economic conditions. This is used for real estate transactions, mortgage lendings, and investment analysis. So this is very much to do with where the property is, how much somebody would pay for it. So this is a transactional sort of value, if I may put it in that terms. Then we look at insurance rebuild valuation. And this is obviously where we test the sum insured on claims. The definition is that it's the cost to restore the property to its original state after the loss. This includes construction materials and labor, professional fees, demolitions and debris removal, compliance upgrades. I believe one should ensure if the policy covers this or not. So this is also something that we need to take cognizance of. It excludes the land value and bulk earthworks. So where we say location in terms of the market valuation on that side, the land value is excluded from the rebuild valuation, and location would be important in this instance where a property may be far from the necessary resources, so increased travel costs if it's a remote location. So this is where I would believe location matters with insurance rebuild valuation. It's used for setting the sum insured, ensuring adequate coverage. And then let's see why does this matter? Well, with underinsurance, this can result in co-insurance penalties or out-of-pocket expenses. Overinsurance leads to higher premiums with no added benefit to the insurer. And claims disputes. Accurate valuations reduce delays and disagreements during claims. I think I just would like to mention in terms of how we get to a good, or when we look at determining the sum insured, a lot of often the published rates from large quantity surveying firms are used to determine the value at risk calculation or the sum insured. And these rates apply to an area is a valuable tool, but it provides good information, but it should be used with caution. Because as I said, there's a lot of variable factors that may come into play. One of it is if it's a remote location, one might look at a structure, think it's standard, and it may not be as standard as one might think. So just be cautious of that. So it's a good tool, but just be cautious. Okay, so how often should valuations be updated? Regular updates ensure coverage remains aligned with actual rebuild costs. Commercial properties, at least every 1 to 3 years, you should have a look at that. High risk or high value assets annually. So to look at these costs. Then the trigger events for reassessment, major renovations or expansions. If it's bigger building, higher material costs, that sort of thing. Changes in building codes or regulations, ensuring obviously that this is covered. Significant market shifts, for example, inflation, material cost spikes, etc. After a claim or a near miss event. And the change in occupancy or usage, that's also very important. I think I've hopefully covered this in a broad spectrum, and yeah, I would like to hand over to the next speaker if that's fine. Thank you.
Thank you very much. I think that pretty much sums it up from all of our panelists. I think that a lot of the information that was shared was very valuable, but also very technical. And it's a good thing to be aware of these technicalities, because these are the things that insurers are going to be looking at in the event of a loss. So it's very important that we reach out to our brokers, our account executives, and ask these sort of questions. And yeah, it's basically just make sure that we are not found wanting in the event of a claim, and that we are not caught unawares. I do see that there are a few questions that have come through. So Peter, I see there's one specifically addressed to you from Tabo. Hello, a quick question for Peter. How and why are sprinkler systems considered to be problematic? So Peter, if you would please give us some insight into that.
Sure, fantastic. Look, I think from what I've found is, okay, if you got a big warehouse, okay, let's talk about our big retailers. What would happen in those instances is you've got, and it's not just there, but it does happen in your it happens in your commercial spaces as well. Unfortunately, sprinkler systems tend to fail for unknown reasons sometimes. Well, not unknown, but I mean a pipe will break or something will. I mean, at the end of the day, you know, they do fail, and that's in essence, you know, over time these things become brittle, and I mean failures do happen. And then what would happen is you'll have a massive flood in the at-risk premises due to the failure of the system. And then what we have to do then, well, the insured is then obviously all these stock in trade and everything is a complete mess. I've done many of those claims in the past. So yes, they do add value, but it can also be detrimental. But depending on, and Kashan know better than me in terms of the requirements of what a building, in terms of the actual building. But yeah, it's quite interesting. Kashan, if you would just want to add something.
Oh yeah. So as Peter said, sprinkler systems can become problematic, but that's if the insured doesn't take care in terms of the maintenance schedules. So a sprinkler system needs to be annually inspected. You then have different regulations or overseen bodies such as ASIP that have more stringent requirements in terms of the maintenance and overseen of a sprinkler system. SANS 10287 states that periodic testing must be done. Also, the quality of water within your wet fire sprinkler systems needs to be checked as well. This is to ensure that you have minimal corrosion of your piping systems and that the sprinkler heads themselves work effectively. You also have to have quite a extensive review after 10 years where the cross sections of your piping is also tested to check for corrosion. Because obviously corrosion is going to affect your nominal diameter. It's going to affect your water flows and pressures as well. So yes, they can be problematic, but only if the insured allows it to get to that point. In terms of its functionality and effectiveness, again, there's a misconception in the industry. People think that a sprinkler system is designed to extinguish a fire. A sprinkler system is designed to contain a fire up until the insured or local authorities can reach the scene, for lack of a better term, and perform fire suppression activities. You may be lucky in some instances where your sprinkler system does extinguish the fire. In that case, you are very lucky, and hey, maybe your sprinkler system is over-designed. May have costed you a bit more. But again, at the end of the day, it's designed to contain a fire. In terms of thatch roofs, the correct term of a sprinkler system on a thatch roof is a drencher system. It's a total flooding system. Again, we've seen a case or an instance where the insured believed the drencher system was the be and all of fire safety when it comes to thatch. This was recommended to him also by consultants, and the wind and intensity of the fire was so great that it overwhelmed the drainage system. So again, in terms of fire safety, you can't just look at one component or one mitigation strategy. It has to be an holistic view. All of these things have to come together to mitigate the risk. We're never going to be able to completely eliminate it, but you can go quite a few steps in mitigation, reducing the likelihood of a fire event. Or if there is a fire event, how can we effectively control it and reduce our losses?
Fantastic. Thank you very much for those answers. Then, Mariette, maybe one here for you, but Tian wants to know, or would prefer to understand if there are any guidelines in terms of building rates to base the value at risk on. His question is the AECOM rates accepted?
Okay, so as I've mentioned, for example, like these published AECOM rates are one of them. It's a very good tool to use, so I'm not denying that. However, one needs to take into consideration if it's a remote location, it might be that materials are more expensive. Sometimes you look at a building, you think to apply a standard rate to it, but when we get to claim stage, the insured gets or presents the claim from a contractor who might have or who might include more expensive finishes. So in essence, when you start measuring the building from foundations and up, you find that where you might have used, I'm just hypothetically using a rate here, say for example you said, okay, 9,000 Rand a square for this building, you've applied it, it looked fine, and then the claim comes and there's quite high finishes included in the claim, and then the claim does not match up in terms of the value at risk. So I think that's what one tends to forget is when it's at claim stages, we look at both the value at risk and the claim in equilibrium to each other. And so the answer would be, in some instances, these AECOM rates might be adequate, but in some instances it might not. So I think what my point of view would be, when you insure the property, to ensure that if the insured feels that they have higher than normal finishes, which at claim stage they would like to be considered, that this needs to be taken into account. So sometimes what we do is we've got a base rate and you add additional costs or rates to it based on specific items. So I think it's not a one size fits all, and I think these published rates also have disclaimers in them to actually state that. So it's just to be aware of that, I would say. I don't know if I've answered your question or so. Yeah, thank you.
Fantastic. And I think from a broking perspective, our recommendation to clients is always going to be to get a professional valuation done. Part of your due diligence process effectively is that. And then also there are all these nuances that play in location, what sort of contractors are available, material availability, and these sort of things. So the best route is to always get the recommendation is to get a professional valuation done. Right, then we have a question from Cindy Nettling. What is the impact of thatch being covered by Harvey tiles? Kashan, is that something that you are comfortable with addressing?
Am I allowed to say no? Look, at the end of the day, thatch under Harvey tiles, you're gonna have moisture entrapment underneath that, which then leads to faster degradation of your thatching material. I haven't myself looked too much into it. I know it's quite a popular design philosophy these days, but I don't have sufficient information or case studies to adequately answer that question.
Okay, well, I mean, if I can maybe try to give some perspective in terms of insurers' stances on Harvey tile over thatch. we've had various experts look into this over the past couple of years. So there are a couple of concerns about it. I mean, look, first of all, you do have this layer now that is protecting the thatch from effectively problems with embers landing from felt fires or external fires landing on the roof would not be as problematic from the roof setting on fire. There is, however, a concern around degradation of that thatch underneath that Harvey tile layer, whether there's correct scintillation and air ventage going through that layer to prevent it from rotting out too quickly. But we have also previously had some feedback from some firefighters that have said to us that when there is a fire that starts on that underlayer, that thatch underlayer, it's very difficult from the outside perspective to be able to isolate exactly where that flame is. So what they need to start doing is start effectively peeling that Harvey tile off the top of that roof to try and locate where those flames are emanating from to try and stop the fire from happening, which can prove quite challenging. So there are pros and cons to both Harvey tile and non-Harvey tile. What I can say is that if there is no thatch underlay, insurers are a lot less concerned with it than if there is a thatch underlay. Okay.
Yeah, just on that, you're 100% Nicholas. So in terms of firefighting operations, when you have a thatch roof fire, water becomes a little bit less effective because it runs off your thatch material. The best practice would be to cut sections away of the roof that's not on fire to prevent the spread of fire, and also limit the loss. So yeah, if you do have Harvey tiles on there, it creates additional time to remove sections of the roof to limit spread. And again, your water, there's additional run of water now, so it becomes very ineffective.
Yeah, good point. Okay, then Ditmar wants to know, does the policy differentiate between fire and smoke damage? Will I be paid out if smoke damages the interior, but flames never reach the rooms? Well, Ditmar, the easiest way to answer that is generally yes. I would imagine that the policy would respond because the proximate cause is effectively the insured peril, which would be heat or some kind of smoke damage due to a flame or residual heat source. As such, the resulting damage would have been due to an insured peril, and therefore there shouldn't be generally a distinguishment between whether the policy would respond or not. I believe that in both instances, they would. But Peter, I see that you want to add something.
Yeah, quite interesting. So we were always trained in terms of many years ago, the saying was no flame, no claim. But that basically relates to singeing and that sort of thing. That's normally excluded. I fully agree with what Nick's saying. I was in Potchefstroom yesterday, where a shopping center burned, and it started in the area where the second-hand car vehicles are being stored. The tenants, unfortunately, around the or joining the car dealership, sustained damage to stock and trade. So what's the damage? The one is a butchery. So you can't sell soot contaminated, smoke contaminated product to the public. Secondly, what we need to understand is, the second one, sorry, is a small little company that sells uniforms to the local schools. Soot and smoke deposits are impossible to get out of clothing. It basically pulls into the fibers. You can wash it, you can do whatever you want. Now, secondly, you can't wash new clothing. That's not even unpacked yet, because then you've got a second-hand product that's no longer new. And then obviously it brings about its own salvage issues as well, because who's going to buy it? So to answer the question, yes, in most instances, it will be. It's not a case of insurers might say if there's a felt fire and your contents have been contaminated by soot and smoke. I can't see them actually rejecting that, but again, stranger things have happened.
Absolutely. Okay, so Almarie van der Sant has a statement. Santam requirements are drenches and thatch retardant. They do not want to negotiate. Kashan, you have put your hand up to deal with that one.
Yeah, because I've dealt with these matters, dealt extensively with Santam. And again, it's just risk mitigation. They want to try everything possible. They're not wrong in this instance to try and minimize the spread and loss. As I made the example with a sprinkler system, a drencher system is designed to slow down the spread of fire and contain a fire if possible. They're not saying that, hey, look, you're going to have a drencher system, you're okay. You never, if you do have a fire, there's nothing to worry about, we'll cover you. No. As anything, they want to go beyond the minimum requirements to ensure they reduce the extent of damage and loss, protecting the client as well. Drencher systems can be a little bit troublesome in the same aspect or regard as sprinkler systems if not maintained correctly. You can experience leakages, resulting in then additional maintenance to thatch roofs or roof structures. And again, make sure that if you do have them installed, you keep record of such maintenance performed, because when you have a fire and we come through and we ask for it and you can't provide it to us, is not good.
Absolutely. Thank you. All right, then I see there's another question from Tian, and he states, if a value at risk was completed on the supplied guidelines and we encounter something like the Knysna catastrophe, how will you consider this at the time of the claim upon completing the value at risk? So Mariette, I believe that's another one for you to give us some insight on, please.
Okay, so I just want to understand that I understand the question correctly. So basically saying is this like in a total loss situation where you've got a sum insured? Is that what we're saying?
Yeah, so he's referencing the Knysna catastrophe. So it would generally be considered total loss. And how would we then consider at this time, the effect of the value at risk upon, sorry, let me just check here. How will you consider this at the time of the claim upon completing the value at risk for the total loss?
Okay, so in the value at risk
rates, sorry.
Yeah, so obviously, like in that instance, there wasn't a lot of information available because some structures burned to the ground, so if I understand. But then you've got, obviously, you try and get as much information of what would the reinstatement be on a like-for-like basis. Obviously, with underinsurance, that might result, depending on if what is left of the property, if there are boundary walls left, or there foundations left. But if nothing is left, I mean, I would say the probability would be that the sum, if it's underinsured or considered that it might be underinsured or adequately insured, it would probably be as close as to the value at risk would probably be as close to the sum insured as possible. However, if the insured comes back with a claim that's higher than the sum insured, obviously insurers would not pay, so the balance would be for the insurer to cover, so that out-of-pocket expense. So I think that's the extent of what I can say around that. I'm not sure, does that answer the question? So I think it's just a question of, we always look on a like-for-like reinstatement, and then that's what it's based on. Yeah.
Okay, thank you very much. I think that brings us to the end of the questions that have been asked. But just to reiterate, there are always going to be many questions around policy response. Am I compliant? Am I not compliant? That is where SATIB and EFI are available to assist in answering some of those questions. And we encourage you to ask your account executives, or you can reach out to us on contact@satib.co.za, and we will direct and answer any queries that might come in from that aspect after the webinar. But it's always good to keep the conversation going. And we'd like to thank everybody for taking the time out today ahead of the weekend to listen to us. And yeah, we hope we've added some value. And we wish everyone a happy and safe weekend.